Welcome to qnawire.
All right, so we got C3H6O2, and we need 7 constitutional isomers that contain a carbonyl, right? So right off the bat, that's 1 carbon and 1 oxygen taken care of, right? So what we have left to deal with is 2 carbons, 6 hydrogens, and 1 oxygen, right? So that's what we have left to add. Now, the thing is that so long as we don't introduce any double bonds, and so long as we don't introduce any cyclic molecules, pretty much as long as we put 2 carbons and then an OH, we're going to be good, right? Because let's just look at one example. Okay, we had a carbon here and a carbon there. Well, at the end of this carbon, there's got to be either 3 hydrogens or 2 hydrogens and an OH, right? So this is kind of what we're looking at. And then the other option is, remember, we could have like, some kind of ether, right? But that's also, no matter what kind of ether we have, going to give us the correct number of hydrogens and carbons. The point is, no matter how we organize this, so long as we draw a neutral molecule, it's automatically going to have this formula, right? And the reason for that is that, you can take a formula like this and calculate what's called the double bond equivalency, and like basically the way the math works out and what valid chemical structures are. This has a double bond equivalency of 2. Of 1. And basically, as long as we include 1 double bond, no matter what we draw, so long as it's valid, we'll have the correct number of things. So all we need to worry about is organizing the carbons and oxygens, and the hydrogens will basically take care of themselves. Okay, so here's 2 possibilities, right? Let's try some others, right? We could do, this, right? And this will also be fine. Oh no, we already did that one. Sorry, my bad. Something like this, right? Because there's going to be 3 hydrogens here and 3 hydrogens there. That's 6, right? So we could do, this would be an ester, another ester. We could do instead something like this. Okay, there's an alcohol with a carbonyl attached. We could do the same thing, but we put the alcohol here, right? We've got options for carboxylic acids, right? So we do like OH there, and then bam, bam, something like that. Let's see, that's 1, 2, 3, 4, 5, 6, and then there's 1 left. I'm not seeing it. Let me start naming these, and then we'll go from there. So what kind of functional group do we have here? That's a ketone, right? It's a double bond to oxygen with carbon on either side. This is an alcohol. Okay. When we put the oxygen right next to the carbon with the double bond, that's called an ester. Okay, and that takes care of both oxygens. There's only 1 functional group. This is another ester, right? Except for it's got carbon on just a methyl right here, and then a methyl on the other side. Whereas over here we had a hydrogen on one side and then an ethyl on the other side, ester oxygen. This again is a version with a ketone and an alcohol. Okay, here we got, this is an aldehyde, right? Because there's a hydrogen here, carbon with double bond oxygen, and a hydrogen on one side. That is aldehyde. Okay, and then this, when we have the double bond to oxygen with the OH, that's a carboxylic acid. Okay, and there's 1 left here. What are we missing? Well, we know we got to have a carbonyl. Okay. Let's see. We did both the esters. We did both of the alcohols. We did this carboxylic acid, but that's the only carboxylic acid we can have. both the esters, both the alcohols. Is there another aldehyde? Oh, dang. Let me think. No, I think the issue is there aren't 7. So I paused the recording and went and found a structural search function on a commercial website that sells chemicals, and this is the only possible isomers for C3H6O2 that also contain a functional group. You could, if you don't need a functional group, then you can just put a double bond or something like that, and this would count. But that doesn't count. It's literally these are the only 6 possible. So the problem is that the question's just a bad question. It's not possible without. Yeah, this is basically literally all that's possible. So that's kind of a bummer. You could have like a non-neutral isomer, but that's not great, right? Like you could have something like this. This would be positively charged, and then you could have like a negative charge there, but that's not an isomer, right? So it's impossible. There's not a 7th. There only is 6. Wait, I guess no, because then if you put an oxygen there, yeah, because then this would change the. This isn't the right formula because you only have 4 hydrogens. Yeah, it's impossible.